Welcome to our exploration of energy sources. Energy powers our lives, from lighting our homes to fueling our cars. But have you ever wondered where this energy comes from? In this video, we'll dive into the fascinating world of energy, uncovering the differences between renewable and non-renewable sources, and discovering how various power plants work. We'll also look at the environmental impacts, the importance of energy conservation, and what the future holds for sustainable power. So let's embark on this journey to understand the sources of energy that shape our modern world. Energy sources are broadly classified into two categories: renewable and non-renewable. Renewable sources like solar, wind, and hydro are naturally replenished and won't run out anytime soon. Non-renewable sources, such as coal, oil, and natural gas, are finite and take millions of years to form. Once used, they're gone for good. Understanding this distinction is crucial as it shapes our choices for a sustainable future. Let's look at some examples to clarify these categories and see why the shift towards renewables is gaining momentum worldwide. Thermal power plants are a common way to generate electricity, especially in many developing countries. They work by burning fossil fuels like coal, oil, or natural gas to produce heat. This heat turns water into steam, which then spins a turbine connected to a generator. The generator converts the mechanical energy into electrical energy that powers our homes and industries. While efficient, thermal power plants have significant environmental impacts due to emissions and resource consumption. Let's see how this process unfolds step by step. Hydroelectric power plants harness the energy of flowing water to generate electricity. The basic principle is simple. Water stored in a dam is released, and as it flows down, it spins turbines. These turbines are connected to generators that produce electricity. Hydroelectricity is renewable, clean, and reliable, making it a popular choice in many regions. However, building large dams can impact local ecosystems and communities. Still, the core idea remains: converting the kinetic energy of water into usable electrical energy. Solar energy is all about capturing sunlight and turning it into electricity or heat. Solar panels, made up of photovoltaic cells, absorb sunlight and convert it directly into electrical energy. This energy can power homes, businesses, and even entire communities. Solar energy is abundant, renewable, and doesn't produce harmful emissions. It's also versatile, with applications ranging from rooftop panels to large solar farms. As technology advances, solar power is becoming more efficient and accessible, helping us move towards a cleaner energy future. Wind turbines are a striking sight on the landscape, their blades spinning gracefully in the breeze. But how do they generate electricity? When wind blows, it turns the blades of the turbine. This motion spins a shaft connected to a generator, which then produces electricity. Wind energy is clean, renewable, and increasingly cost-effective. It's especially useful in areas with consistent wind patterns. As more countries invest in wind farms, this technology is playing a growing role in the global energy mix. Geothermal power plants tap into the Earth's internal heat to generate electricity. Deep beneath the surface, the Earth's core produces immense heat. Geothermal plants drill wells to access this heat, often in the form of hot water or steam. This steam is used to spin turbines, which then generate electricity. Geothermal energy is reliable and available year-round, making it a valuable renewable resource. However, it's most effective in regions with significant geothermal activity, such as volcanic areas. Biomass energy comes from organic materials like plants, wood, and animal waste. These materials are burned or converted into biofuels to produce heat and electricity. Biomass is considered renewable because new plants can be grown to replace those used for energy. It's a versatile source, used for heating, electricity, and even transportation fuels. However, sustainable management is key to ensuring that biomass energy remains environmentally friendly and doesn't contribute to deforestation or pollution. Tidal energy harnesses the power of ocean tides to generate electricity. As tides rise and fall, they create powerful movements of water. By capturing this kinetic energy, we can produce clean, renewable electricity. Tidal energy is predictable and reliable, as tides follow regular cycles. However, building tidal power plants requires careful planning to minimize impacts on marine life and coastal environments. Still, it's an exciting frontier in the quest for sustainable energy. Tidal power plant works by capturing the energy of moving water during tidal changes. Typically, a dam or barrage is built across a tidal estuary. As the tide comes in, water flows into a reservoir. When the tide goes out, the stored water is released, spinning turbines that generate electricity. This method is highly efficient and produces no emissions, but it can affect local ecosystems. Tidal power plants are still relatively rare, but they hold great promise for coastal regions. Solar energy offers a range of benefits that make it an attractive choice for individuals and communities. It's clean, producing no harmful emissions or pollution. Solar panels can be installed on rooftops, reducing the need for large power plants and transmission lines. Solar energy is also renewable and abundant, available almost everywhere the sun shines. As technology improves, the cost of solar power continues to drop, making it more accessible to people around the world. At the heart of solar panels are photovoltaic cells. These special cells are made from materials like silicon that can convert sunlight directly into electricity. When sunlight hits the cell, it excites electrons, creating an electric current. This process is clean, silent, and highly efficient. Photovoltaic cells are used in everything from calculators to large solar farms, making them a key technology in the transition to renewable energy. Energy conservation means using energy more efficiently and reducing unnecessary consumption. Simple actions like turning off lights, using energy-efficient appliances, and insulating homes can make a big difference. Conservation not only saves money but also reduces the demand for energy production, which in turn lowers pollution and conserves natural resources. By making smart choices every day, we can all contribute to a more sustainable future. Using fossil fuels like coal, oil, and natural gas has significant environmental impacts. Burning these fuels releases greenhouse gases, which contribute to climate change. It also produces air pollutants that can harm human health and ecosystems. Mining and drilling for fossil fuels can damage landscapes and water sources. These impacts highlight the urgent need to shift towards cleaner, renewable energy sources to protect our planet for future generations. Energy transformation is the process of changing one form of energy into another. In power plants, chemical energy from fuels is converted into heat, which then becomes mechanical energy as turbines spin, and finally into electrical energy. This chain of transformations is essential for delivering usable power to our homes and industries. Understanding these steps helps us appreciate the complexity and ingenuity behind modern energy systems. Energy efficiency means getting the most out of the energy we use. This can be achieved through better technology, improved design, and smarter habits. Efficient appliances, LED lighting, and well-insulated buildings all help reduce energy waste. The significance of energy efficiency lies in its ability to lower costs, reduce pollution, and conserve resources. It's a key strategy in the global effort to create a sustainable energy future. Smart grid is an advanced electricity network that uses digital technology to monitor and manage the flow of electricity. Unlike traditional grids, smart grids can respond to changes in demand, integrate renewable energy sources, and improve reliability. They use sensors, communication systems, and automation to optimize energy use and reduce outages. Smart grids are essential for supporting the transition to a cleaner, more flexible energy system. The future of renewable energy sources looks bright. Advances in technology are making solar, wind, and other renewables more efficient and affordable. Governments and businesses are investing heavily in clean energy, driven by the need to combat climate change and ensure energy security. As storage solutions improve and smart grids become widespread, renewables are set to play a dominant role in the world's energy mix. The shift to sustainable energy is not just possible, it's already underway. Fuel cells are devices that convert chemical energy directly into electricity through a chemical reaction, usually involving hydrogen and oxygen. Unlike traditional combustion, fuel cells produce electricity cleanly, with water as the main byproduct. They are used in a variety of applications, from powering vehicles to providing backup energy for buildings. Fuel cells are efficient, quiet, and have the potential to play a significant role in the future of clean energy. Wave energy conversion taps into the power of ocean waves to generate electricity. Devices placed on or near the surface of the sea move with the waves, and this motion is converted into electrical energy. The principle behind this technology is to harness the constant movement of water, which is a vast and largely untapped resource. Wave energy is renewable and has great potential, especially for coastal regions with strong wave activity. Energy storage is crucial for balancing supply and demand in modern energy systems. Technologies like batteries, pumped hydro, and compressed air storage allow us to save excess energy for use when it's needed most. This is especially important for renewable sources like solar and wind, which can be intermittent. Effective energy storage ensures a stable, reliable power supply and supports the integration of more renewables into the grid. Power plants are the backbone of our electricity supply. Whether they use fossil fuels, water, wind, or sunlight, all power plants work by converting some form of energy into electricity. Each type has its own advantages and challenges, but all play a role in meeting our growing energy needs. Understanding how these plants operate helps us make informed choices about the energy we use every day. Renewable energy is growing rapidly around the world. Countries are setting ambitious targets for solar, wind, and other renewables, driven by environmental concerns and the need for energy independence. As costs fall and technology improves, renewables are becoming the preferred choice for new power generation. This growth is transforming the energy landscape and opening up new opportunities for innovation and investment. Despite their many benefits, renewable energy sources face some challenges. Intermittency, when the sun isn't shining or the wind isn't blowing, can make it hard to provide a constant supply of electricity. Integrating renewables into existing grids requires new technology and investment. However, ongoing research and development are addressing these issues, making renewables more reliable and efficient every year. Hybrid energy systems combine multiple sources of energy, such as solar and wind, to provide a more stable and reliable power supply. By integrating different technologies, these systems can balance out the strengths and weaknesses of each source. Hybrid systems are especially useful in remote areas or places with variable weather, ensuring that energy is always available when needed. Distributed generation refers to producing electricity close to where it's used, rather than relying on large centralized power plants. Rooftop solar panels, small wind turbines, and local biomass plants are examples. This approach reduces transmission losses, increases energy security, and empowers communities to take control of their energy needs. Distributed generation is a key trend in the move towards a more resilient and sustainable energy system. Governments play a crucial role in shaping the energy landscape. Through policies, incentives, and regulations, they can encourage the adoption of renewable energy and promote energy efficiency. Many countries offer subsidies for solar panels, set targets for renewable energy use, and invest in research and development. These actions help accelerate the transition to a cleaner, more sustainable energy future. Communities are increasingly taking an active role in energy production and conservation. Local initiatives, such as community solar projects and energy cooperatives, empower people to generate their own power and share the benefits. Education and awareness campaigns also play a vital role in promoting energy-saving habits. When communities work together, they can make a significant impact on the transition to sustainable energy. Innovation is driving rapid change in the energy sector. New materials, smarter grids, and advanced storage technologies are making it easier and cheaper to harness renewable energy. Research into hydrogen, next-generation batteries, and artificial intelligence is opening up exciting possibilities. As innovation continues, we can expect even more breakthroughs that will shape the future of energy. As we've seen, the world of energy is diverse and constantly evolving. From traditional fossil fuels to cutting-edge renewables, each source has its own role to play. The shift towards cleaner, more sustainable energy is essential for protecting our planet and ensuring a brighter future for all. By understanding how energy is produced, used, and conserved, we can make informed choices that benefit both people and the environment. The journey to a sustainable energy future is underway. Let's keep moving forward together.